Welcome everybody in the lecture hall, welcome everybody on Zoom, welcome everybody from the future. Today I'm going to finish this part on syntax, hopefully, then we wrap up for the week. More precisely, I'm going to look into XML. So I explained yesterday why syntax is important. There are two aspects. There is first the fact that syntax is more important in big data than it was in the 70s. Because I told you, remember last week about data lakes, that we can just drop data on top of some storage layer. And so we need this data to be files, right, that we drop there. And an example is JSON lines, files, XML files, and many other different formats. Now, in a system like PostgreSQL or a typical database that is not a data lake, you don't really need that form of syntax because you let the system handle the underlying mapping to the persistent storage for you, right? So syntax plays a more important role in big data. The other aspect is that it should be human readable. You should be able to open it also so that it stays for longer. And at the same time, machine readable, as we will see, because we want to query it with data. And finally, we needed syntax that breaks the rules, because if we just stick to CSV, we will not go very far, because CSV was built for relational tables, right, when it's flat and homogeneous. And now we have syntax, XML and JSON, that applies to heterogeneous collections of nested data. So we break rules. All right, so I covered JSON yesterday, and now I'm going to cover XML. So I told you XML used to be a hype 20 years ago. Everybody was talking about XML. There was plenty of papers on XML in conferences, in research, and so on. And then at some point, the hype faded away. JSON took over. And so a lot of people started dismissing XML, saying like, this is the past and so on. But the thing is, maybe in academia, but in reality, it's actually there and widely used. So for example, if you go to, now the toolbar just came on top of that in the Zoom room. So yes, you can see it now. So this link right here, these are the e-governance standards in Switzerland. And the tax offices use them a lot. So the underlying data is all in XML, and even the QR codes are in XML. And you can see how it's really centered on the names of the elements. I will come back to what an element is, but you see cantonal tax, federal tax, taxable result increase reason. You can see that they have a good sense of humor in the governance standard. This is actually on the website, what you see here. All right, it's a sample, of course. That's not a real report, obviously. So what do we have in XML? So just like JSON, I told you the building blocks, and I will do the same with XML. So you might remember that in JSON, we have a lot of curly braces for the objects, and we have a lot of square brackets for the arrays, right? Well, in XML, we use angle brackets. It's these smaller than, greater than signs. These are also called tags because we actually tag some text with these. Some people refer to XML as the tag soup for this reason. So an opening tag looks like this. It's just some name that is enclosed in these angle brackets. And then we close it with this slash. It's a little bit like in many countries, when you leave a city, it's the same sign, but with it's crossed. So you can see it as leaving foo. So it's the end of foo. And basically, it's opening and closing because, in fact, there is something in the middle. This is called an element, and an element has contents. This is the content of the element. And inside, you can have whatever you want. It can be more elements and so on. We'll look later. But it's just like in an array in JSON, you can have anything. In an object, you can have anything. So between these tags, you can have anything. So this is an opening tag, a closing tag, and together they form an element that's called the element foo. Now, we computer scientists are a bit lazy. So if you have empty contents, you would basically have an opening tag and a closing tag with nothing in between. But because we are lazy and we don't want to write it twice, we have this shortcut, but it's really just a shortcut where if you put the slash at the end, that's just a shortcut for opening and closing immediately with nothing in between. So, right, so just make sure you see that if it's at the beginning, that's a closing tag. Here it's an empty tag, right? And you can still write this if you want. It's the same, right? But it's just taking more space. We'll see that it doesn't matter in memory, right? This is just the syntax in text, but once you parse it and put it in memory, it doesn't have to take that much space. But I'll come back to that in the coming weeks. All right, for whom is that clear? An element? Okay. The names of the elements are very important. Again, as I said, when you draw standards, it's really heavily centered on the name that you give to the elements that actually have a meaning in real life. We also call that taxonomies. So these are elements. Then you have attributes inside an opening tag or an empty tag. You can have key value pairs, and the key value pairs are called attributes. So you can have, you basically have an equal sign in the middle, and on the left you have the name of the attribute, and on the right you have the value of the attributes. The name of the attribute doesn't have any quotes, it's just like this. And the value is double quoted or single quoted, but you need the quotes. Now, if you know HTML, you know in HTML the quotes are not required, but in XML it's very strict, right? You really are required to put some quotes in there. So you can have, of course, multiple attributes in the same elements, but this is another building block of XML, right? So elements, attributes. Then we have text. Text just goes in between the tags. There is no quotes. Unlike JSON, you don't need to quote the text. You just put it directly because the angle brackets already give you the limits of the text. Now, why don't we have any quotes and so on? Well, it has to do with the history of XML, which historically has been pushed a lot by the publishing industry, the publishers, the publishing companies. For example, you will find a lot of scientific papers or books that are at some point converted to some XML format. It probably makes sense, right? Because if you know what an HTML page is, it's a bit the same. On an HTML page, you have a lot of text, and then you might know that you have tags for bold, italic, and so on, at least at the beginnings of HTML. So this is really, XML at first was really text-oriented. You just put a lot of text, and then you tag the text by adding these angle bracketed elements in the middle of it, right? So just remember that historically it was pushed by the publishing industry. The ancestor of XML is called SGML, but it was so complicated, also used by the publishing industry, that XML came as a simplification of HTML. So you might find some features of XML that are strange or coming out of nowhere. Well, in fact, this is just because it's inherited from SGML. It's just, you can almost see it as archaeology. It's an archaeological artifact of the ancestor of XML. All right. So yes, this is text, and you can just put whatever text you want in between tags, between an opening and a closing tag in an element. So elements, attributes, text, and comments. So I told you about this archaeological stuff. This exclamation mark dash dash is an archaeological artifact that dates back to SGML. This is the way it is. It's just like that. And then you finish the comment with dash dash, right? So there was a lot more constructs in SGML that have disappeared, but this one survived. There is a difference between comments in XML and comments in a programming language like C++ or Java. It's that if you put comments in a programming language, then these comments are actually discarded. It's really meant for humans, but they are dropped. Once you compile, it's all forgotten. An exception could be the documentation comments, right? Like Javadoc and so on, that actually can be used for other purposes. But other than that, the comments are discarded. In XML, that's not the case. When you parse with an XML library, you open an XML file and you parse it, and then you programmatically process what you parse, you will see the comments. They will be forwarded to you. So they are not just discarded. When you parse XML, you see the comments. So they belong to the syntax as well. And finally, this one is actually kind of special. It's not really a building block, but it's just something you might see at the top of the file, which declares that the document is XML, right? So it helps you determine that this is an XML document. again, this opening bracket and question mark, blah, 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 is archaeological artifacts coming from SGML. But this is just how it is. XML version 1.0. There's also a version 1.1, but the difference is not really so big. So for practical purposes, you don't really need to worry. It has to do with the handling of encodings and international alphabets. And then the encoding of the file, by default, if you create one, just use it UTF-8, right? But it would support other encodings than UTF-8. So that would be the way the text is actually saved in bits on the hard drive. This is optional, but if you see that, then don't be surprised. This is just what might occur at the top of an XML document. Now, there are other building blocks than that. I'm just sticking to the 80% of the cases. There's some others, but they disappeared or in use, they are less used than before, or they are a bit less relevant for data purposes. So this is why I'm not bothering you with them, right? So elements, attributes, text, comments, and then maybe what's called the text declaration at the top of the file. Okay, so now this is actually an XML document. It is well-formed. Remember, I told you to use the word well-formed, not valid. Valid we'll see in 2 weeks. So it's a well-formed document. So what can you see? Well, it has the text declaration that just says this is XML. So this one doesn't really count. And then you have one element. It's called the top-level element because it's not inside anything else. You can see that it's an empty element, right? Has a slash at the end. So it's an empty element, foo, nothing inside. So this is one of the simplest XML documents you can have. Well, there's even simpler. It's if you omit the text declaration because it's optional. So you can also just have this. You just need to know that it's XML. Then you probably need to put the extension to the file .xml or something so that you at least know what you're dealing with. Okay. So this is one of the shortest XML documents that you can ever have. Even shorter would be just with a single letter, and that you cannot do any shorter than that. Okay, so this is well-formed. This is well-formed. This is not well-formed because you can only have one top-level element in an XML document. Only one top-level element, and here you have two. You have foo and then you have bar. You cannot have that in an XML document. Only exactly one top-level element, not 0, not 2, exactly 1. Okay, so this is not okay, but this is okay. Here, there's only one top-level element, that's foo, right? You see the opening tag foo, and then 2 lines later, the closing tag. And in the middle, you have a nested, you see nestedness, a nested element bar that is in the middle. But this is fine because that second element is inside foo. It's not a top-level element. For whom is that here? Right? Okay, so we have one top-level element, and that's totally fine. So now you can see in between the tags, you can have text, but you can also have nested elements. This is not fine because you cannot have text outside of any elements. At the top level, text is forbidden, right? So this is not well-formed. That would be an error if you try to open that. You can have comments though on the top level. Comments are fine, but not text and not additional elements. This is fine. Here you have text that is nested within an element. And look at what's happening. You see, there is a top-level element, then some text, and then some nested element, and then some text again. This is what XML can do that JSON cannot do, at least not so easily. So you see here, this is why you see how the publishing industry uses that, because you really have text like a scientific paper, and then in the middle of the text, you can annotate and tag some of the text in the middle. For example, in HTML, do you know the BR tag, right? For a new line. So this is the sort of tags you can have. So instead of bar, it could be BR, meaning that's a new line. So text BR text just means you go to the next line, right? Okay. By the way, another name for the tags is markup. This is why it's called XML, right? Extensible markup language. Okay. Here, that's not well-formed because we try to put an element inside the tag, inside the opening tag, right? That you cannot do. That sort of nestedness is not allowed. You can put it in between, it's fine, but not inside a tag. So if you have a tag, you cannot open another element. That's not okay. All right. And of course, you can have attributes inside. Here, I'll come back to that. The problem with this one is that you have this symbol, this character that normally is for opening a tag. It's normally not allowed to have it anywhere else than for actually opening a tag. So this is here what would cause the issue. All right, but I'll come back to how to escape these characters. This is fine, right? Here we have one top-level element. It has one attribute that has the value element. It's called attributes, and bar. Okay, that's a nested. So this is just to give you an impression. Now you might sometimes see that's also optional, a doc type inside. We already saw doc type HTML in an HTML file, right? This is kind of the same thing, right? So it basically says this is a document, the type of which is, and then you have the name of the top-level element. Always have to be the name of the top-level elements, right? So this is why doc type HTML, because HTML is the top-level element in an HTML file. Okay, so right. So the doc type is actually something that can get much more complex than this, but it's considered maybe not obsolete, but let's say it's been superseded by newer technologies like XML schema, which we'll see in 2 weeks. But historically, in the doc type, you could also have some constraints on the structure of the document. To basically say that this element can only have these and these nested elements inside, and so on and so on. But I'm not going to include that in this course, so you don't need to worry about that. I'm just telling you there is this doc type. If you see something inside, then you know that's called DTD, right? But we are not going to talk about them. What else can I say? Yes, a word about HTML. HTML is a cousin of XML. They both come from HTML, but HTML is not necessarily XML. What actually happened historically is that it kind of forked. And there's the HTML community and the XML community, and they have different mindsets. And there was, for a little while, a debate between these two communities. So the mindset of the XML community is you need strict rules for well-formedness. To say that a document is well-formed, you have to follow the rules. You have to quote your attributes, you have to close the open tag, and so on and so on. So it's very, very strict. HTML is more lenient. In HTML, you don't have to quote the attributes. You don't even have to close your tags. For example, BR can just be just the opening tag and nothing else in HTML, in the HTML syntax. That's totally fine. Plus, you can even, you don't even need to throw an error if there's a problem. Did you know, I don't know if they still do it, but did you know that, for example, Google opens the HTML pages with HTML and then head and body, right? You know, in the HTML syntax, what you have. But if you look at the bottom of the page, at least last time I checked, there is no closing body and closing HTML, just to save energy. And the reason it's done is simply because the browsers are not going to complain about that. So you see, it's really a different mindset than XML. In XML, you would complain if you're not closing the tags, the elements properly. Now what happens is that when HTML5, the fifth version of HTML was designed, the debate was still on. Like the XML community tried to push HTML5 to strictly adhere to XML. That's what we call also XHTML, right? So that HTML should strictly follow the XML rules. Went on for years and years. It was even regularly in the news, at least the technical news. And at the end, a compromise was reached. It's a lot of people in the working group. I remember there was once a tech plenary where I wasn't in that working group, but I could see like there was 100 people in there. And you can imagine the time that it takes for everybody to express their opinions from all the companies. But the compromise that was made is we are going to have two syntaxes for HTML. So there's the data model of HTML, and then we have the HTML syntax, and we have the XHTML syntax, and they both live their own life. So XHTML will strictly follow the XML rules. The HTML syntax will not. And there is even some people who try to make everybody happy with something called HTML polyglot, that tries to both parse as HTML and as XHTML, right? To be even nicer. So you see, it's a complicated thing. But I wanted to tell you that so you know the link with HTML and why is it that HTML looks a lot like XML, but with some differences. Okay. Now HTML is for web pages. XML will use it for data, for storing actual data. So it's not just XHTML. So this is a summary of what I told you. So elements, only one at the top level, then you can list them. Attributes can only be in the opening elements tag, or the empty tag is fine too, but not the closing one. Text can be in between elements, neither at the top level nor inside tags. And comments can be at the top level or between tags, but not inside tags, right? So this is just a summary of what can be where. Now, just like I did for JSON, a few do's and don'ts. Just like in JSON objects, you should not repeat the keys. In the same XML element, you are not allowed, that's strict, you are not allowed to have twice the same attributes. So here, if you have foo and again foo, that's not okay, that's going to be an error. You will not be able to open that or parse that. You can have multiple attributes as long as they all have different names. For whom is that clear? All right, very good. Then, have you heard in theoretical computer science of well-parenthesized expressions? Right? It's a bit similar. The way you close your tag has to follow a rule. So for example, if you open tag A and then you open tag B inside tag A, then you need to close B first and then close A, right? So it means that B, closing and opening and closing, must be fully inside A. You're not allowed to intertwine them. So intertwine, I don't know. So A, open, close. You cannot just open B inside A and that's it, and then close B outside. That's not allowed. You really have to open and close it first before you can close A, right? So think of well-parenthesized expressions, but more general. You have a question on Zoom? Does it work? Let me see if maybe it's the way it's connected. Oh, it's not switched on. Go ahead.
Okay, nice. Can you have the same argument name, so the key, in different tags?
In different tags, yes, absolutely. If it's a different tag, then you can repeat the attribute. In fact, it happens a lot because typically a tag with the same name will typically have similar attributes. And we'll see that when we look at schemas a bit later. Yeah, that's a good question. This is really within the same tag that you cannot repeat them. Just like in JSON, it's within the same object that you cannot repeat the keys. All right. So you see, in fact, that means that the attributes within a tag follow a key value model, right? The attribute name is the key and the attribute value is the value. Okay. All right. So the well-formedness, you really have to properly nest the tags. And I said I would come back to this smaller than symbol. So it's also for historical reasons, but also practical reason, is that if I show you that, you probably would be able as a human to parse it, right? So you open, you close, and then this is one smaller than two. In fact, that could be JavaScript in HTML. So now the thing is that this character here, smaller than, is really something that the parsers, the XML parsers, rely on to find the tags. For this reason, you're not allowed to just use that symbol as is because it will confuse the parsers. So this is why XML forbids it. You cannot use that symbol for anything else than opening a tag. That's the only use that's permitted. But now comes the question, what do you do if you really want to have one smaller than two as text, right? And then the answer is you escape it. Escaping is something you know from many languages. In JSON, we use backslashes, as is very common. In XML, we don't use backslashes, we use ampersands, right? This end symbol here. LT means lower than, and then the semicolon, right? So this is an escape sequence. I have good news for you. There's only 5 of them. LT, lower than, GT is greater than, apos is for the apostrophe, quote is for the double quote, and amp is for the ampersand itself. If you know HTML, you know that in HTML, there's many, many others, but that's HTML. In XML, there's really only these 5. If you want more, you can define them, but I'm not showing you how. Okay? So these are just these 5. Now there's a story I like to tell about the ampersand symbol. you know that today the English alphabet has 26 letters, right? A through Z. Well, it used to have more. Some of them actually survive, like the thorn, I think it's called thorn letter in Icelandic is still present. So you still have traces of these letters, but they just disappeared in the English alphabet with time. So it was replaced with TH, for example. The ampersand is actually one of these letters that disappeared from the alphabet, even though it didn't quite disappear completely because we still use it. It's just not in the alphabet. But it used to be in the alphabet. And you know that this symbol is used to say end, right? When you use it as to mean end. German people might use a plus symbol more than this one, but in English we use that. It's actually, if you know a bit of French, you can also see it if you look very carefully as ET, right? E, which means end in French. That's kind of the E here and the T. So historically, it also has to do with this. But basically, why is it called ampersand? Because when you teach it to the kids at school, that was in the 19th century. In the 19th century, you would go A, B, C, blah, 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 X, Y, Z, end. And so it was weird to say just X, Y, Z, ends. That sounds very, very strange. So they tried to make it more poetic. So they basically said, because it's by itself at the end, so by itself, you can also say per se. So basically, they said, okay, X, Y, Z, and per se, end by itself, end. So X, Y, Z, and per se, ends. And when you say it very fast, and per se, end, it's X, Y, Z, ampersand. And that's why ampersand. It's a contraction of and per se, end, right? Just for historical anecdotes that you can tell to your friends. Okay, so ampersand, and we use that for escaping, and then the semicolons here. Okay. Now, why do we need to also escape quotes, not just this one? It's because of attributes. Because if you have an attribute like this that is double quoted, you cannot have a double quote, so you just use the escape sequence, right? Likewise, you cannot use this inside an attribute value. It's also not allowed, so you use the escaping sequence with LT, right? If you look at everything, it's actually quite simple to retain. These two here must be escaped everywhere. If you want just a lone ampersand and smaller than, wherever this is, in text, in attribute values, you must escape them always. On top of that, in double-quoted attribute value, you also must escape the double quote for obvious reasons. And in single-quoted attribute values, meaning the apostrophe is used as a delimiter, then you must escape the apostrophe. So you see, this is well-formed. Here, it's fine not to escape this, but these two you must escape, smaller than ampersand. Here, it's fine to not escape the apostrophe inside double-quoted. It's fine to not escape double-quoted inside of double-quoted, but you must escape this. Okay, so there's only 5 to remember, and these are the rules. Now, regarding the XML names, it's actually pretty simple because that's pretty much like in many programming languages for the names of variables in C++, in Java, in Python, and so on. So should be very intuitive for you. For example, it cannot start with a number, like you don't start a variable with a number in Java. It cannot contain any special characters. The underscore is fine, the dash is fine, the dot is fine, but you cannot have, for example, this as part of an element name, not allowed, even escape, that doesn't work. Now, the XML ones are reserved. You're not allowed to create them, except if it's part of a standard. This is just something reserved by the standardization body at W3C. So if you do it, nobody will complain, but you're not supposed to. Right? I will tell you what they can be used for, but don't do it on your own. Okay? Anything that starts with XML, in any case, you cannot do. Okay. Now, generally, and again, that's not going to surprise you. It's really just think of Python variables or Java variables. You can use letters plus the underscore, and you can use, but not in the first position, digits and the colon, I'll come back to it, and the dash and the point. Right? But just not at the start, just like you do not start a variable name with the digits, right? So this is it. And all the other characters, it's just not allowed. Okay? So this is this is really just natural. Just think of variables in Java and in many languages. It's pretty intuitive. Something else, just like JSON actually, is that the white space is not really relevant. We like, just like for JSON, to nicely indent and add new lines and just to make it readable by a human, right? You don't have to. You could also just put it all on one line, but it's convenient for humans to actually view it in this way. In fact, many editors of XML or JSON have a magical shortcut where you can copy paste any XML or JSON, and it magically makes it readable like this. This is called pretty printing also, right? So just does it for you nicely indented. Okay. All right. And now I'm going to a feature of XML that some people hate. But it's actually, in the enterprise world, in the standardization and company world, it's actually important. We don't have this in JSON. So this is one of the limitations of JSON. So let me start with modules and functions in any language. You know that in Python, when you define functions and you create a library, you put it in a module, right? And that module can be put on as a pip package, right? On pypy.org. Not sure if the pronunciation is correct, but basically you give it a name and everybody agrees on that name, and then you can do pip install and with the name of the package, install it and so on, and then import in order to use it. So basically when you create functions, you organize them nicely in modules. In Java, that's called a package, right? In Java, you have packages, and inside the packages, you might have classes and methods. Now, you know that within the same package, you cannot have any collisions. You cannot have two classes with the same name in the same package, but it's fine to have two classes with the same name if they're in different packages, right? And that's what packages are for. It's in order to keep it tidy and avoid collisions. Well, the same thing happens with XML. Because you have all of these governments and standardization bodies and all the users of XML, they come up with names for their elements. For example, you saw them for the tax purposes, like revenues and so on. These are possible names for elements. Well, we need to keep it tidy because if millions of people are doing that, at some point, it's going to clash. People are going to create elements that have the same names, and that is actually problematic. Just a simple example here that is recurring is clients. You might have an XML environment in which it's for networks, like client server. And then maybe you have the CRM, customer relationship management of a company, where we use the word client for a person or a company, right? That is your client. When you want to put constraints, as we will do in 2 weeks on what can be in these elements, you need to distinguish between them. But if they have the same name, you cannot really distinguish. So for exactly the same reasons that you nicely group in a tidy fashion functions, Python functions in modules, and Java classes in packages, we also do the same for the element names. And that's called a namespace, right? I think in C++, you also have namespaces. If you know C++, it's also called a namespace there. So that's to avoid that. So we will nicely tidy that up. So this is, prior to tidying up, this is what an XML document could look like, where you didn't bother to create any namespace. That's like the default package in Java. So here it's not anywhere. If you want to nicely put it in a package, this is how you do it. You use something that starts with XML. So this is one of the reserved uses. You basically say, this is my namespace. This is like the name of a package in Java, like the name of a module in Python, and so on. You just put it in there. But we're all lazy, so we are not going to repeat it everywhere. So you just say, OK, let's have the shortcut M for this. Can be anything, just call it M. And then you add M in front of every element. And that means that all of the elements that have M as a prefix are in that package, right? Now, you might wonder, that's a URL. I should be able to type that in my browser. So, you know, it's weird that we just use that for a namespace. But the thing is, remember in the REST API paradigm, or in general, that's the mindset of the W3C, there's the concept of a resource. A resource can be absolutely anything. And in the W3C, we love to use URIs for resources. A package is a thing, it's a resource. So we also give it a URI. Now, it turns out that it has established itself historically that we use the HTTP scheme in the URIs for namespaces. But it's really just a historical reason. it will not work in your browser. It might have a fancy page that has some explanations, but it really has nothing to do with HTTP, right? So don't let yourself be confused by the fact that it starts with HTTP. That's really just a convention, right? So URI starts with HTTP. The idea here is just that when you create your namespaces, you should only create them in a domain that you own, right? Nobody would prevent you to create a namespace in any domain, but it's just to be nice to other people. Just create the namespaces when you design elements in a domain that you own. Okay? Does it make sense? Well, actually, maybe it doesn't make sense that we use HTTP for a namespace, but yeah, that's just how it is. We just have to take it for how it is. Okay, so that's the mathml package. It actually exists. It's markup language for mathematics formulas, just like LaTeX. It exists. It's defined somewhere as a standard, and it defines all of these elements like the root, apply, and so on. EQ, equals, and so on. So that's mathml. If you don't even want to bother with a prefix, you can use what's called the default namespace. Then you just use XML like that, and you say, okay, that's the default, and anything in there that is in that document, unprefixed, belongs to that namespace. This is exactly the same. This is exactly the same thing. Here we use a prefix. Here we just use the default namespace, right? That is not the same. Here there's no namespace at all. And if you are a government or a standardization body and you define elements, you should not be in no namespace. You should always tidy things up and put it in a namespace, right? So this is a lot, but it's not a good idea if you're the tax office and you want to design some XML. Okay, do we have a question?
Sorry, so I don't quite understand why we need namespaces. The example you give in programming languages, the thing is I can import other things, right? That's where the clash happens. But if every file is just separate, when does the clash happen?
It's basically it's a practical reasons, because here I'm just showing you the syntax, right? So it's true that you could put in syntax colliding elements, and at first it seems like it doesn't create any trouble. But the same goes in Java, right? People could create Java files in the default package that have the same names. If they just use it on their own machines, it doesn't clash, right? But if somebody tries to use the two together, then it's going to clash. So now this typically clashes if somebody is using XML data from two different sources and tries to query it. And the reason is that when you query it later, you might filter by element name. You want to say what are all the revenues for all the tax reports that I have in there, for example. Then you rely on the element names. Another reason you rely on the element name is for validation that we'll see in 2 weeks, right? You might require that a specific element must have a specific structure. And you want to keep it tidy when you do that. You really want to make sure that every element is uniquely known as belonging to a specific namespace. And in the same way that you can import modules in Python, you can also import namespaces in XML. But you do that when you validate the documents. You do that when you actually constrain the structure of the documents. And then it's important that it doesn't clash. Does it make sense?
Yes, but the question is what happens with the default namespace then? Like let's have 2 files in the default namespace, but I have the XMLs on top.
So what's going to happen if you put everything in the default namespace and you even put your schemas in the default namespace, what's going to happen is that when you try to validate, you will basically have 2 specific constraints for the same elements. And when you try to import everything, it's just not going to work because you will have conflicts between the constraints on the elements. So it's going to start causing all sorts of issues, right? So this is the reason you really want to, you really want the element names in XML to uniquely specify what they are about and to uniquely specify the constraints that they have. Right?
Thank you.
But I'll come back to validation in 2 weeks.
Just on that, then there is no difference between no namespace and the default namespace because you're going to have collision in both ways. Or what's the difference?
So there is a difference because here, if I have the default namespace, let's say I have these documents. There is somewhere a specification and a schema, but we'll cover that in 2 weeks, that basically says what the constraints are. For example, it might tell you that CI must have the name of a variable inside, that you're not allowed to have other elements. It might tell you that CN must be an integer, for example, probably for constant, right? So it basically defines some constraints of that on that structure. And so what happened is that if you're aware of this namespace and on the fact that it expresses constraints on these elements that are in that namespace, then when you process that document in a proper enterprise environment, then knowing that it's in that namespace is going to enforce the constraints and throw errors at you if you do not put the tags in the way that they're supposed to be put. Now, if you do it like this, then there is no schema for this. So here you could do anything you want, but you have no idea if you're doing it right. So again, the idea is that the moment you put it in a namespace, it makes it possible to actually tie it to a schema for that namespace and then constrain the structure of the documents. If you define the schema like this, with no namespace at all, then you might have multiple people doing the same thing, and then you will have a problem when you try to validate the document because there will be multiple sources of truth to define what you can and cannot do. Does it make sense?
But also with the default namespace, there could be multiple
default
schemas.
namespace. Yeah, so the default namespace really says that everything here belongs to that namespace. The mindset is that it's really the same here. This is the same thing. So if you have a default namespace, these are not in no namespace. These are in this namespace.
Okay,
Here?
it's not a namespace that everybody is using. It's just, I see, sorry.
Yeah. So this is basically saying that this is the namespace of all these elements here. And it's the same thing as this, right? Here, none of this is in any namespace. That's the difference.
Okay, I had misunderstood
Yeah.
the default namespace.
Yeah.
Thanks.
Awesome. All right. And so the idea, this is called the QName. The idea is that you bind the namespace to a prefix, and then you use the prefix right here to say that this element is in the namespace that you would where you would find the binding here. So technically, the name of an element is made of a prefix, a local name, and a namespace. But when you compare them, it's really just the local name and the namespace that matter, because the prefix is only a shortcut. It's only a way to bind it. In fact, you do the same with Python. When you import a module, you might bind it with some name just for the file that you're in, and then you use the name that you tied it with, right? So it's exactly the same when you import a module in Python, right? When you use as, I think. All right, I think there's even memes on that how to confuse somebody like import pandas as NP or something, right? Just to confuse people. It's a bit the same. So here too, you can actually bind it to whatever you want, and the prefix is not relevant. It means that all of these are exactly the same. Only the prefix changes, but it's the same namespace. And even that one is the same. This is where it's the default namespace, so you don't have any prefix here. But again, it's the default namespace because of that, right? These are all the one and same thing, no difference. All right, now it's very easy to get confused with namespaces. So what you should do, and that's a very, very strong recommendation that I have, if you ever declare namespaces, do it at the beginning in the root elements, only here. Just like in Python, when you import your module, you do it on the top of the file and that's it. You don't import in the middle of the file, right? So only import at the top in the root elements, do not put it anywhere else. For example, I could say here's a namespace, bar, and another namespace, foo, and then you can use both of these, the elements in these two namespaces. So I put it in blue and in red, and you might have somewhere a schema that says what the constraints are for these elements, and somewhere else a schema for that namespace that says these are the constraints for these and these elements. For example, the constraint here might come from the tax office, right? And the tax office says this must be used in that way. And the constraints here might come from FINMA, for example, for financial reports. And then it tells you this has to have this and that structure. So really think of the namespaces just like names of modules in Python, except that instead of being functions, it's constraints that we are talking about. But that I'll come back in 2 weeks on the constraints, right? I didn't intend to go too much in these details. For whom is that clear? Right? Okay. So really think that behind every namespace, there is a government authority or some association or whatever that handles that namespace and that decides what it's for. MathML, HTML is another example. There's an HTML namespace that says how XHTML has to look like and so on. Okay? So that's going to be, for today, my last slide. Only use namespaces like this. Either no namespace at all, but be very careful. Don't do it if you're a government or a public. Avoid no namespace at all. It's just you can do it. You can use a default namespace or a one prefix namespace. This is really the same thing. Or you can combine namespaces, multiple ones in the same document, where you use multiple sources for your data and you combine it. But never use the default namespace in that case. That's just too confusing, right? So give them all a prefix if you use multiple namespaces, right? So this is it. Thank you very much for following. I'm almost done, actually. Just last week I'll finish up. And then we'll study white column stores, in fact, the next time, with how to store XML and JSON in some storage layers that looks like tables. So thank you very much. Enjoy the exercises. And I'll see you next week on Tuesday at 2 for the continuation. Thank you.